case, if this is the case, so what I'm saying that if your D is in this interval, okay, it's like in this wall, okay, then I'm saying this will happen. So I'm saying that now take basically within this wall, take a radius 1 over n. So this delta could be anything because this is true for every delta. So I'm choosing what delta to be 1 over n. So I can draw a ball of radius 1 over n, and then I can pick a sequence down from it. Then I can draw another ball. So it's like first I've drawn a ball of radius 1 and choose a pick x1, and then I'm drawing a ball of radius 1/2 and then choosing x2 from it, and then I'm choosing a radius 1/3 and I'm choosing x3. So by that way, I'm having a sequence actually. I'm having a sequence actually which converges to it. Okay. Now this implies that xn converges to A. Yes. Okay. What does this will imply by hypothesis? F of xn approaches to L in Y. As m goes to infinity. Great. But can you see a relationship between this and this? So this means that df of xn is less than epsilon, okay? While here you have something which is opposite. So that's a contradiction basically. So because these two things can't have simultaneously happen. Has contradiction. Contradiction non-linear, even if you don't take contradiction. If I say that I would like to prove the contrapositive of this state. So this also fits simple basically contrapositive. If this does not hold, then this cannot hold up. So we took the negation of this and it implied the negation of first statement. So the definitions are something for you to do and exercise. Prove that limit, such as if limit x converges to a f of x is L, then L is V. You can't have more than one limit for one function. Done before. Okay. Do you have any questions for me? Are you happy with this? Yes. Yes, we have.
we seem to politically define this.
Remember that? You can find plastic.
So it means we are going to visualize it into eight spaces.
Okay. But very analysis needed is excellent part.
Those are the notions of all what we are using.
So in other words, if we can prove something easily in mutual spaces, then why not to prove the general results rather than sticking ourselves in that? Okay? In some situation, we can't do it in.
We are treating R as a beauty. We can simply treat R as the political space and all do all these things.
Logical space. Is every mutual space a logical space?
We haven't done this result yet.
Space is a logical space. You have metric space on any topological space. Not all topological spaces are meterizable. Some spaces you can define mutual on them. There are spaces which you are defined.
But our mutuals are
Mutual spaces, spaces Y plus.
just space.
Just take collection of open balls. What are the open sets in mutual spaces? They are open balls. So that just take their connections. So we know that basically finite intersection of those balls, open ball, not closed.
Yes, sir.
Finite intersection of open balls is open. Arbitrary units, union of open balls together. X is open, empty is open. So graph problem. Okay. People want to have some break, huh? Some people are done. Enough of it today. So let's move towards the continuity. Let's move towards the continuity. So we defined what is the meaning of limit. Now I would like to define what is the meaning of what's continuity? What's the intuition behind continuity? At a point. And then I have two spaces. X and Y. Okay.
corresponding एक opening wall X में होगा जो A को contains.
Okay. But would like to have an intuition. What does continuity really serve?
So they ask me point eight minutes. The player in this point.
Just one. Means that continuous maps are something very interesting. Why they are interesting? They are interesting because they do something interesting. And something that is very interesting is that if you take 2 points, okay, which are close to each other, okay, and if your function is continuous, when you transform those 2 points, they will still be close. Right? So if I have 2 points, I have 2 points which are closed here, okay, and if I am applying a continuous function on them, then after application, your image is also still going to be closed. So in other words, closeness is kind of preserved under continuity. closeness is preserved under continuous. This is something very interesting. So if a function is continuous, we know that if we are taking some set of points which are close to each other, okay, and we transform them, then we know that after transforming them like f to all those points, continuous function to all those points, they will still stay close. Yeah, the measure of closeness could be different actually. Okay, that's fine. But they are going to close that. But imagine if f is not continuous, what does it mean? So we can have any crazy thing happen. Things are close, but transform them in something really crazy happened. And one is at South Pole, another is at North Pole. Right? So this closeness property is really interesting. Okay? This closeness property has a huge application side in mathematics. And so f is continuous at A. What should be the meaning?
Limit exists.
Limit exists.
This is from a these like
Shouldn't say like that. We should say that okay, for epsilon positive, there exists a delta positive such that whenever x and a are close enough,
f of x
okay,
from f of
then f of x and f of a
will
are going to be closed as much as you want. Okay. So we can already see this closeness here actually. So if I want these two numbers to be closer than this, then I have to make these two numbers, or in other words, closed points which are close to each other are mapped onto
close points.
points. According to definition is saying after transformation they are going to still close.
Say
Okay. Here's a little pillar. I don't need to prove it. This follows from what we have done previously. Let us say that f is continuous at A at x equals A if and only if x approaches to A, f of x equal to f of A. Okay? This should be in y actually. This is not just a limit, but a limit in meter space y. And it has a meaning. We know that what it means. So continuity is equivalent to basically verifying this cycle. Function agrees with value of function at that point. Why this should be true? Why this should be true? We have done almost everything about it. That's what you have to prove that f of a barabar hai.
So, but this theorem is finished.
This only this theorem is enough.
And the continuity definition.
This theorem is saying nothing about quantity. This theorem is characterizing definition of limit in the terms of sequences and in the terms
Here-
of Epsilon delta.
For L, we have f of a.
Uh-huh.
One side is the same.
what does follows from this definition? From this definition, it follows that the f of a is a limit of the function if x goes to a basically. So yes, f of a is a limit. Okay. But you need also this uniqueness actually. So if there is any other limit L, okay, whatever f converges, okay, it should be equal to let's say. Okay, so the limit can't be different from f of a. Okay? Previous fact, combining uniqueness can not just previous fact. Okay, you can somehow, I mean, if you agree that okay, this is essentially true, then from that result you can directly get this result that f of a is the limit of f of x as x goes to. In other words, if we have this, then we should have this. So this is different only. So it means that if we have this, then we must have this. And I'm saying this, that probability definition says that this should happen with
F of A.
f of a. So if this is true, then the substitute L to be f of a. Agree? Something that we have done before. Let's do it again.
पानी खपे तो
हाँ,
पानी खपे तो
फर्क रखा ना होता है।
सर हम बैठे हैं फिर भी चक्कर है यहाँ तो सर हम बैठे हैं फिर भी चक्कर है यहाँ पे 2 घंटों
So I'm enjoying it. So I'm enjoying doing mathematics and I'm enjoying looking at your faces. I have my own sympathies. Okay. So imagine I have 3 metric spaces, x, y, z. Okay. And then E is a subset of x. And after the map from E to Y. Okay. And G is a map from the range of F till Z. Okay. If F comma G are continuous, let me state precisely. Let me state precisely. And let H is a map from E to Z such that it is a composition.
Yeah.
It's a composition of this. Essentially, that's what we want to say, that if F and G are continuous at a point, then H is going to be continuous. Okay, so you don't, okay. You need to be careful. We need continuity. So, let me say it more precisely. So if F is continuous, we say F composition here, G composition. G should be G composition. F is from E to Y, and G is splitting Y is into the actual base. So if F is continuous at x equals to A,
It's
and
is continuous.
G is continuous at
If
what?
F of X.
Then H is continuous at x equals to A. Agree?
G is
F of x and F of A. So Agree? So that's what we like to prove. So help me out with this loop right here. Like a really simple thing. We also did this in calculus 3, okay? That why this should be true. So I would like to prove the continuity of x at a. I would like to prove the continuity of h at x equal to a. So to prove continuity of something, we have two ways. Either I can take sequence approach, or I can take what? Epsilon delta approach. Yeah, so I'm proving it through one approach, but do it through other approaches as well. It should be fun to do. So let us take an epsilon. So that epsilon is positive, and we like to find basically delta. And this epsilon is what? This kind of an object. H of x and h of a. Agree?
Z.
Huh? In Z.
Z.
And this is less than epsilon. Okay. So if this is the case, just think about it. So let's do kind of a scratch work first, and then write a clear proof. Actually. So let's do scratch work first. Let's do scratch first. So if this is the case, that's what we want actually. The question is from where I should begin. Okay. So. Okay, one way is that I can go like this way after we at x. So let's do this way. So let epsilon is positive. Now as f is continuous at x equal to a, so there exists. And delta, I would like to reserve delta for h. So I'm saying let's take eta positive. Such that what? So distance between x to a less than eta implies distance between f of x and f of a is less than epsilon. Okay. Take this epsilon.
The B in Y. It's metric in Y.
Okay. This is in y. Okay. So I like to keep the same epsilon. Why should I keep the now as G is continuous at f of a, what does it mean? So we're going to say that so there exists. So this implies take delta to be epsilon itself. This implies that d of z of g of f of x and g of f of a. Agreed? We say that. Because for the continuity of G, like this plays a kind of a role of delta.
Yes.
Did he?
Yes, sir.
You may ask a question, which I am asking to myself, that why it should be the same epsilon? If this is something, why it should be the
Epsilon 1 2 of bar is straight line. The charge everything. Straight line में हम epsilon 1 2 तक देंगे. Last में हम change कर सकते.
So one way was that we go forward and try to do it. But in that we are having a gap actually. Because we want h of x and h of a to be smaller than this epsilon. Okay? Question is why this should be this epsilon? That's what. So in forward approach there is a gap. Let's go backward actually. Okay?